also 12th standard chapter only. It is also 12th standard chapter only for us here. Okay. So chemical kinetics. Chemical kinetics. What is the chemical kinetics? Do you have any idea about the chemical kinetics? The chemical kinetics is completed or not completed?
No, sir.
They didn't complete. Okay. So what is the chemical kinetics means here? So chemical kinetics is branch of physical chemistry, so which deals with the study of chemical reactions and their reaction mechanisms. Okay, so what is the chemical kinetics means here? So what we are going to study under the chemical kinetics means here? Chemical kinetics is, it is the branch of physical chemistry, so which deals with the study of chemical reactions and their mechanisms here. Okay, actually chemical kinetics is the Greek word. Kinesis, kinetics. Okay, what is the kinetics here? So kinetics is nothing but motion here. Kinetics is nothing but motion. So according to that one, we are going to study about the chemical reactions and the reaction mechanisms we are going to study under the chemical kinetics. Okay. So first of all, so chemical reactions we are talking about. So we have a different types of the reactions. Okay. We have different types of the chemical reactions or not? Ritu? So how many types of the chemical reactions are there for us? Generally,
Is it 2, sir?
types of chemical reactions. Types of chemical reactions. So 3 types of the chemical reactions are there here. So how many types of the chemical reactions are there for us means here? So 3 types. How many types means here? 3 types. So what are the 3 types of the chemical reactions we are having?
The decomposition, combination, combustion.
That is not that is the redox reactions. Okay, that is the redox reactions here. So we are talking about very fast because of chemical reaction, rate of reaction. Okay, chemical kinetics. Kinetics is motion. Okay, motion is nothing but, so some chemical reactions are, they are going to be completed very fast. Some chemical reactions are they completed very slow. It takes days, months, years also. Okay, some moderate reactions are there. So that kind of reactions, based on the completion of the reactions, chemical reactions are classified into 3 types. Okay, so rate of reaction generally we can call. Rate of reaction is nothing but speed. Based on the speed, we have 3 types of the chemical reactions. So what are the 3 types of the chemical reactions we are having means? One is very fast reactions. Very fast reactions. So which we can call as a very fast reactions means here, the reactions which are completed within a fraction of seconds. The reactions which are completed. The reactions which are completed, which are completed within a fraction of seconds, within 10 to the power of minus 14 to 10 to the power of minus 16 seconds. 10 to the power of minus 14 to 10 to the power of minus 16 seconds is called as a very fast reaction. Is any possibilities that to observe that kind of reactions?
So sodium reacting with air when it's kept outside.
Okay, so that is also. Is any other reactions are example? In laboratory, you are going to do the experiments nowadays. Okay, Ritu, already you had done some practicals. Otherwise, they had to start the practicals.
We have to start, sir.
Okay, not
We
yet
have
started.
done, no, sir, we have done some estimation values and all.
Okay, so now actually, so we are doing some salt analysis and volumetric analysis. It is that. Okay, so volumetric is nothing but an estimation reaction. In estimation reaction, we are doing as acid-base neutralization, KMnO4 versus more salt and KMnO4 versus oxalic acid it is said. Okay. In that one, Ritu, you are telling that estimations are you had done. Which estimations you had done, Ritu?
Hydrochloric acid, sir. That's like the
Hydrochloric
only.
acid. Yeah,
Yeah,
hydrochloric acid versus base you are treating. Is it right? Sodium
yeah,
hydrochloride.
sir.
Okay. So what is the indicator you are using? That we are using some
Ethylene
indicator.
bromide. I guess ethylene.
Phenol, methyl orange indicator and phenolphthalein indicator we are using actually. Okay.
Ah,
So
yeah,
why
sir. Yeah.
we have to use the phenolphthalein indicator for the acid-base neutralization means here generally acid also it is the colorless. HCl is the colorless. Aqueous solution of the hydrochloric acid also it is the colorless. And aqueous solution of the sodium hydroxide also it is the colorless. So whenever you're titrating with the sodium hydroxide with HCl, we can't find out the end point. That means we can't find out where the HCl is neutralizes with the sodium hydroxide. To identification only we are adding as a phenolphthalein indicator. So phenolphthalein indicator it acts as a weak acid. It is a weak acid. In acidic medium, it is colorless solution. Whenever you add base, slowly it turns into the pink color, light pink color. That is the end point generally we can call. Wherever you put as the end point, that it represents as a acid is neutralized with the base. Okay, so acid base neutralization. We can't find out immediately. Just you add one drop of NaOH also immediately changes the color within a fraction of seconds they are going to be change the color. So that kind of reactions it is not possible to read and study also. Okay, that kind of reactions are we can call as a very fast reaction. The reactions which are completed within 10 power minus 14 to 10 power minus 16 seconds is called as a very fast reaction. Sir, what are the examples of the very fast reactions means here? One is acid base neutralization, HCl. Aqueous solution of the HCl is reacts with aqueous solution of the NaOH. It forms salt plus water. What is the salt it is forming? NaCl plus water is going to be formed. Clear? Next one. What is the another one means here? Identification. Salt analysis, some reactions are there. Identification of the chloride ion, identification of the sulfate ions also here. For example, here if any aqueous solution is there, for example NaCl we are taking aqueous solution of NaCl. So aqueous solution of NaCl is treated with aqueous solution of the silver nitrate AgNO3. Immediately just you are adding as a 1 or 2 drops of the silver nitrate to the aqueous solution of the NaCl. Immediately it gives us a white color precipitate. Curdy white color precipitate you will get. So what is that curdy white precipitate means? It is nothing but AgCl. It is nothing but silver chloride. Okay. It forms as a silver chloride. What are the byproduct it forms means? Sodium nitrate is the byproduct. Aqueous solution is containing here sodium nitrate. So this it get as a white PPT. White P. And another confirmation test. Detection of the sulfate ion. So just I'm talking about the practical knowledge now. So Rithi, you're having anyway practicals now. Identification of the sulfate also. Okay, identification. This is the confirmation test of the sulfate, chloride ion. So what are the second example I had given here? That is the confirmation test of the chloride ion. Sir, how we are going to identify the chloride ion present in a given salt means if the aqueous solution is treated with aqueous solution of the silver nitrate, it forms as a silver chloride plus sodium nitrate. Whatever the silver chloride it is formed, that it will be present in white precipitate. How it is present means in the form of white precipitate. Okay, another one. Here, barium chloride is there. BaCl2. Aqueous solution of the barium chloride. If the aqueous solution of the barium chloride is treated with, so dilute sulfuric acid. The dilute sulfuric acid means immediately it forms as a barium sulfate. So barium sulfate also it exists in the form of white PPT, white color precipitate. It is also formed as a white color precipitate. So these are the some different reactions we are having for the very fast reaction. This kind of reactions we can't expect also in how many seconds they are going to be completed. Okay. Clear? Still anyone you having doubt? If you do the practicals means you will get idea. If you add means immediately they convert the form as a some precipitate. Immediately they change some one color to another color also. Okay? Ritu, do you have any doubt?
No, sir, got it.
Sir, we can also take pH indicators as fast solutions, right? Like fast reactions.
pH indicators means
Like when we are
pH.
adding
No.
pH indicator.
Actually, pH indicator we are using to find out the acidic strength and basic strength. We are not taking for the to find out the reactions here.
No, like they can be considered as very fast reactions, right? Like in a way.
Yeah. Yes. Okay, that is also we can take here. So because of it shows the strength, na immediately pH paper. Litmus papers also we can consider as a very fast reaction. Okay, acids, if you want to find out what you are taking here, you are taking as a blue litmus. When the blue litmus, if you place in acid means immediately turns into the red color, na? That is also it is the very first reaction only.
Yes, sir.
Okay, next. Here, very slow reactions are there. Very slow reactions. Very slow reactions. Sir, what is meant by the very slow reactions means here? Reactions are which completed, they may be hours, they completed hours or days, months, or years, months or years. So that kind of reactions are we can call as a very slow reaction. Sir, what are the best examples of the very slow reactions means here? So simple known example. What is a known example means here? Reaction of hydrogen gas with oxygen gas at room temperature. At room temperature to form as a water molecule is very slow reaction. Whether it is very slow reaction or very fast reaction, ma'am. Atmospheric air is containing hydrogen gas also it is there. Oxygen gas also it is there. Actually, especially in summer season, even Hyderabad also sometimes we used to get as a water scarcity. We can get or not? Water scarcity is there in summer season in Hyderabad or not?
Yes, sir.
Okay, so we are getting as a scarcity. If atmospheric air is having large quantity of the hydrogen and oxygen means by using that one we cannot convert into the water molecule. We can convert or not? If we convert means we won't get as a water scarcity. Is it right?
Convert, but it will take a lot of time.
Yes. Okay, it converts at room temperature. Actually, they does not react with one another. Okay, to react together means we have to change the reaction condition. We have to take at high pressure and low temperature. Some reaction conditions are there. Then only hydrogen is reacts with oxygen molecule to form as a water. Okay, so but at room temperature it does not react with oxygen. And another one it is there. In atmospheric air, carbon it is there. And oxygen gas also it is there. Okay, so reaction of the carbon with oxygen at room temperature also it takes so much time to form the carbon dioxide gas. Okay, it is also takes so much time. Okay, and what are the another examples means here? Decomposition of the living organisms also one of the best examples. Decomposition of the living organisms. What is the example means here? We are talking as a biodegradable. What is the biodegradable, ma'am?
So something which can decompose naturally without any external forces.
Very good. Simply what we can say means here. So dissolving of the substance, okay, by the soil microorganisms in a soil. Okay, the solubility of the substance by the solubility of the substance in a soil by the soil microorganisms is called as a biodegradable. Okay, sir, what are the examples of the biodegradable means here? Plants also we can take, animals also we can take here. If you see plants and not all is there somewhere if you are going to place after a few days, they are going to be decomposed. Completely they undergoes to the decomposition and they mix into the soil. Okay, at the same time some animal bodies also it is there, they are going to be dissolved in a soil. All that are we can call as a biodegradable. Okay, so to dissolve in a soil it takes us time here, they maybe takes us a days, some plants are they take as years also. Okay, here what is another example means here, rusting of iron. Rusting of the iron also it is a very slow reaction or very fast reaction. Rusting of iron, rusting of
It's
iron,
a very slow reaction. It can take days.
it is also we can take as a very slow reaction. So when we can take the rusting, what is mean with the rusting? Rusting of iron, you are telling that. What is mean by the rusting? How the iron is going to be rust?
So when the topmost layer of iron reacts with the moisture in the air, then it forms a layer of oxide which basically tarnishes the entire metal.
Very good. It is correct only. So when the metal is exposed to the atmospheric air, to the water and air, oxygen gas means it loses their no, actually it tensile strength. Because of iron is it undergoes to the oxidation reaction. Okay, it loses its changes, that is only we can it forms as a oxide layer. So that is only we can call as a rusting of iron. Okay, it converts into the oxide. Pure metal is converts into the metal oxide. That is only we can call as a rusting. Okay, next here moderate reactions. Moderate reactions. Sir, what is meant by the moderate reactions means? Moderate reactions. Moderate reactions mean the chemical reactions which are completed within a time is called as a moderate reactions. What is meant by the moderate reactions, ma? The chemical reactions which are completed, the chemical reactions, which are completed, which are completed within a particular time, within particular time, particular time is called moderate reactions. Okay, what are the examples of the moderate reactions means here? Decomposition of the hydrogen peroxide. Okay, decomposition of hydrogen peroxide, H2O plus O2. It forms as a, so 2 moles of the hydrogen peroxide is, it undergoes the decomposition reaction and it forms as a water molecule and it releases the oxygen gas. Okay, and what is the another reaction we are having means here? Decomposition of the nitrogen pentoxide, N2O5. If 2 moles of the N2O5 is, it undergoes the decomposition reaction to form N2O4 plus 1 mole of the oxygen gas is going to be released. Clear? And what is the another reaction means here? Hydrolysis of the ester. Hydrolysis of the ester. So what is the general formula of the ester functional group, Ritu? General formula of ester functional group. Ritu.
I don't know.
Don't have idea. Aditi?
Sir, RCOOR dash.
Very good, man. So it is a general formula of the ester functional group is here. RCOOR is called as a general formula of the ester functional group. Okay. Hydrolysis of the ester. Ritu, you have a carboxylic acids na chapter.
Yes, sir.
Aldehydes, ketones, carboxylic acid. So there you will get as a carboxylic acid esters here. Confirmation test
I
of the
could.
carboxylic acid. Confirmation test of the carboxylic acid. Esterification reaction, particularly one reaction it is there. It is a very, very important question to you also. Esterification reaction. So what is meant by the esterification reaction means when the carboxylic acids are treated with ethanol in presence of concentrated sulfuric acid. to form as a ester. Okay, so whatever the ester it is, after forming the ester, you will get as some fruity odor. Fruit smell you will get chemical reaction. If you do that chemical reaction means, so you will get as some fruit smell. If you got some fruit smell with that, it represents as an esterification reaction.
Sir, is it also used for soap formation? Like we learned it in 10th grade.
It is also used for
Soap formation. We learned it in 10th grade.
soap formation. So that is the different soap formation. Okay.
So we learned esterification in that one.
Esterification also we can do here. Esterification means first it undergoes the hydrolysis reaction, basic hydrolysis reaction. As per you're telling that, that is all I'm going to be explaining here. So esters are there. For example, CH3 bond, COO, C2H5 is there. So this we can call as a ethyl acetate. Okay. When this ethyl acetate is, it undergoes to the basic hydrolysis. It undergoes to the basic hydrolysis. If it undergoes to the basic hydrolysis means it forms CH3 bond COONA plus C2H5OH. So Aditi, whatever you are telling that na, so this we can call as a, this we are using in the soap formation. Sodium stearate we can call. Okay, sodium stearate. So sodium stearate, sodium laurate. Okay, all are the ester
We
functional
also
group.
use potassium stearate.
Potassium stearate or sodium stearate, potassium lauride, sodium laurate also it will be there here. All those substances are we can use in the preparation of the soaps. Clear? And one more also it is there. Hydrolysis of the sucrose. What is the molecular formula of the sucrose? Molecular formula of the sucrose. C12H22 H22O11. This we can call as a sucrose. When the sucrose is, it undergoes to the hydrolysis reaction. Okay, when the sucrose is, it undergoes to the hydrolysis reaction. It forms glucose plus fructose. What is the molecular formula of the glucose? C6H12O6.
O6.
As fructose, C6H12O6. So one is called as a glucose. Another one is called as a fructose. Another one is called as a fructose. So all these components are we are getting by the hydrolysis reaction. All these are we are getting is here hydrolysis and decomposition reaction. Okay, so this one is heated at high temperature, undergoes the decomposition. And one more reaction also it is there. When nitrogen dioxide is reacts with the carbon monoxide. If this reacts with the carbon monoxide means it forms as a nitric oxide plus carbon dioxide gas is going to be formed. Plus carbon dioxide gas is going to be formed. Another one is NO plus Cl2. NO plus Cl2 means it is also formed as a NOCl2 nitrosyl fluoride we can call. Okay, all these are the examples of the moderate reactions. Moderate reactions means we can say the reaction is completed in a particular time here. That kind of reactions are we can call as a moderate reactions. Now you got it all of you? What is, how many types of the reactions are there for us here? Based on the completion?
Yes, sir, got it.
So based on the completion, we have a 3 types of the reaction. What are the 3 types of the reactions are there means? Very fast reactions, very slow reactions, and moderate reactions. Okay. Very fast reactions are going to be completed within how many seconds, ma? How much
10 to
time?
the power
10 to the
minus
power minus 14 to 10 to the power minus 16.
Very good, Ritu, and very good, Aditi. So 10 to the power of minus 14 to 10 to the power of minus 16 seconds they are going to take to complete the reaction. Okay, here, next. Here, the main concept now we are talking about rate of reaction. Rate of reaction. Okay,
So much can you scroll up? I'll just note down the examples.
I'll forward the PDF file in the group. Ma? Okay, anyway, I'll scroll down. Got it? This is the basic hydrolysis. Basic
Done, sir.
hydrolysis. This reaction is basic hydrolysis. The second reaction is acidic hydrolysis. Acidic hydrolysis. Okay, same this reaction you'll get again biomolecules chapter. Okay, then Aditi.
Yes, sir.
Then we'll go for the next concept. Okay, so what is the next concept we are having means here? Rate of reaction. Rate of reaction. So here onwards, the main concept is start for us here. Chemical kinetics. So chemical kinetics very important in JEE level. You know that one? We have a more weightage also. Every time without missing compulsory they're asking the question in JEE level. One question from solutions, one question from chemical kinetics, electrochemistry. Compulsory they'll ask the questions. Okay. Now, so what is mean by the rate of reaction? So rate of reaction, how we can define the rate? Rita is giving answer.
Is it the change in the reactants or products?
Very good, Ritu. Okay. So rate of reaction is nothing but it is change in concentration of the reactants. Okay. Rate of reaction is defined as it is the change in concentration of the reactants. Concentration of reactants
With respect to time.
With respect to the time. So change in concentration of reactants or products along with the time. Okay, along with the time is called as here rate of reaction. Okay, so what is meant by the rate of reaction means rate of reaction is defined as it is the change in concentration of the reactants or change in concentration of the products along with the time is called as a rate of reaction. Okay, so based on that one, how we can write the units for the rate of reaction? Units for the rate of reaction?
Sir, is it molarity per time?
Very good one. So concentration generally we are taking as a molarity we are taking. What are the units of the molarity means here? Mole per liter. Okay, mole per liter. That means that we can write as a liter inverse. So mole liter inverse divided by what are the units of the time? Units of the time is equal to second only na. According to that one, how we can write the units of the rate of reaction means units of the rate of reaction is equal to mole liter inverse and second inverse. Okay, what are the units of the rate of reaction means? So the units of the rate of reaction is equal to mole liter inverse and second inverse. Got it? Next, here change in concentration. This we can study deeply more here. Okay, so change in concentration of the reactant. For example, I'm going to write as some chemical reactions here. Okay, so you know how to write the chemical reactions. First of all, you know how to write the chemical reactions. Okay, so now I'm taking the reactants. So reactants, which side we can write in a chemical reaction? Either we can write as a reactants at left hand side or right hand side.
Left hand side.
Left hand side. While writing the chemical reactants always we can write as a left hand side. Okay, and products always we can write as a right hand side. Okay, products we can write. So reactants I'm representing with capital R. Okay, reactants I'm representing with the capital R. So products I'm representing with the capital P. Okay, now reactants are converted into the products. Okay, so reactants are converted into the products means initially the reactant concentration it will be more. Slowly, when the reactants are converted into the products, okay, that time the concentration of the reaction is going to be decreases only, na? The concentration is going to be decreases or not?
Yes, sir. It will decrease and products concentration will increase.
Product concentration is going to be increased. That means initial concentration of the reactants, it will be more. Initially, product concentration, it becomes as a 0. After some time, the reactant concentration is going to be decreases and product concentration is going to be increases. So that is also we can represent with graphically. We can represent or not, sir? So how we can represent means,
Yes,
let
sir.
us see. So we are taking graph, we are taking the concentration on. So concentration on x-axis. Okay, I'll write here. So two graphs I'll get.
So it is the same thing like equilibrium, right? The graph of products and
Graphs.
reactants.
Yes. Okay, it's same thing only. So concentration we are getting on the y-axis. Time I'm taking on the x-axis. Time I'm taking on the x-axis. Concentration I had taken on the y-axis. Now I'm taking as a reactant. So along with the time, you're telling that concentration of the reactants are going to be increases. Decreasing of the concentration can be represented and like this here. So this it represent as a concentration of the reactants. Okay, and similarly, how we can represent the concentration of the products? Let us see.
Increases, sir.
Increases. Now, so concentration I'm taking on the y-axis and time I'm taking on the x-axis. Okay. Now, if the time is increases, the product concentration also is going to be increases. Product concentration also is going to be increases. Okay. So it's called as initial concentration. This is the P1 we can take and this we can take as a P2. So this we can take as a initial concentration. Okay, R1. This we can take as a R2. Okay, the time we can take here. In this place, time we are taking as a T1. So here time we are taking as a T2. Here also time we are taking as a T1. And here time we are taking as a T2. So this as per the rate. Okay, how we can represent here? How we are going to represent this one means here change in concentration. You are telling that rate of reaction. So rate of reaction is equal to change in concentration of the reactant. Change in of concentration of the reactants. That means here R2 minus R1 only na. Final concentration minus initial concentration. Okay, divided by change in time. Change in time means how we can write as here T2 minus T1. Similarly, okay, with respect to the products, how we can write the equation P2 minus P1 divided by T2 minus T1. So this is also we can write as a delta R divided by delta T. And this also we can write as a delta P divided by delta T. Now in this my question one. Now my question is in this experiment. So which of the value will get as a positive and which of the value will get as a negative? Which one you will get as a negative? Ritu.
Sir, the reactants will get us negative and products will get us positive.
Very good,
I do.
Ritu.
So
Aditi,
products will be positive and reactants will be negative.
very good, Aditi. Okay, so which one you will get as a positive, which one will get as a negative means products will get as a positive value and reactants will get as a negative value. Sir, why we will get as a negative value means here R2 value is less than that of the R1. If the R2 value is less than that of the R1 means automatically we will get as here negative value. But condition is that. So rate of reaction never be positive, never be negative. Okay. So what is the condition means here? So rate of reaction it always be positive only. It never be negative. So now you got the condition. Okay. Rate of reaction. Rate of reaction. It always be positive only. Positive only. It never be negative. Okay. It always be positive only. It never be negative. Okay, so why it never be negative means here rate of reaction condition. Sir, how we can convert the negative value into the positive value means here? So you have to multiply with change in concentration of the reactants with the negative sign. If you multiply with -1, okay, if you multiply with -1, if you multiply with -1 means how much you will get as a, so minus delta R by delta T only you will get now. Will get or not, ma? Okay.
Yes, sir.
So to convert the rate of reaction, actually rate of reaction always be positive, it never be negative. To convert the negative sign into the positive also, we are multiplying with the -1. Whenever you're going to be multiply with -1, then it becomes as a minus into delta R by delta T and delta P by delta T also we can get. Okay. Clear? In this one more importance also it is there. So we have some importance with the negative sign and we have some importance with the positive sign. What is that importance here? In this one, negative sign is indicates decreasing the concentration of the reactants. Positive sign is indicates increasing the concentration of the products. Okay, now you got the clarity. In this one, what is the negative sign it indicates here? Negative sign is indicates here decreasing the concentration of the reactants. Positive sign is indicates increase the concentration of the products. Got it? Every one of you? Okay. Negative sign. Negative sign indicates decreasing concentration. Decreasing concentration of reactants. Okay, and positive sign. So positive sign indicates increasing concentration of products. Concentration of the products. Got it here, all of you? Is that clear until here? Still anyone you're
Yes,
having
sir.
doubt? Okay. In the next class, we will discuss about the type of reactions again. So that means here we have two types of the rate of reaction can be expressed into two types. Instantaneous rate of reaction and average rate of reaction. Okay. Then we'll slowly go for the next concept here. Until here, clear, everyone?
Yes, sir.
Right. So then we will continue in the next class. Thank you all. Thank you, Aditi, and thank you, Ritu.
Thank you,
Thank you.
sir.
Thank you.